All right, so here's our problem, guys. We've got a 0.6 kilogram ball, and it's moving at a speed or a velocity of 2 meters per second. That's at point A. At point B, it's got a kinetic energy of 7.5 joules.
And it probably has the same mass.
Yeah, it's the same ball, so it's got the same mass. And what we want to know, the ball's kinetic energy at point A, so KE at A. We want to know the speed at point B. And we want to know the total work done between A and B. So let's go to a slide where we have some blank space and do that. First thing we want to know is the kinetic energy at point A. You had to remember the equation. Kinetic energy is what? 1/2 mass times velocity squared. So KE is 1/2. The mass is 0.6. It's got to be in kilograms, so your kinetic energy will come out in what units? Joules. It's got to be in kilograms, not grams. You get joules, that's kilograms. The velocity was 2, so I'm going to square my 2. So you don't really need a calculator for this. This is going to be 4 over here when we square it. Times 1/2 is going to give us 2. And 2 times 0.6 is going to be 1.2. It's going to be 1.2 joules, Newton meters, or joules. That's part A. Part B, find the velocity at part B. Well, for part B, we're still going to have to use the same equation. But we know in part B, they gave us the kinetic energy at B. The kinetic energy at B was 7.5 joules. The mass, 0.6. So all we need to do is solve for B. So let's multiply both sides by 2. Divide both sides by m. And then we'll take the square root of both sides. So if we plug in what we know, 2 times the kinetic energy, which was 7.5. I'm going to go ahead and write those joules as Newton meters so we can cancel out some units. Divided by the mass. The mass was 0.6. Now we've got to take the square root of all of that. Now, so what you got to do is you got to go 2 times 7.5 divided by 0.6, and then take the square root, so it's 5. And to think about the units, we know what the units ought to come up for. We're trying to find, what are we solving for here? Trying to find velocity, so we know it ought to be meters per second. But let's think about why it's meters per second.
It's only 260.
Only 2? Okay. Well, remember that a Newton is a kilogram times a meter per second squared. We're multiplying that by a meter, and then we're dividing all that by a kilogram. So you ought to see that the kilograms are going to cancel, and we've got meters times meters, meters squared, over second squared, and then we've got to take the square root of all that. So it comes out to be meters per second. Now, let me make a little space here, and let's think about part C. Part C, it wants to know how much work was done moving this ball from point A to point B. And all you've got to know to figure that out is that work equals change in what? Kinetic energy. So the kinetic energy to begin with, we just calculated at point A was 1.2. So at A, that was the kinetic energy. The problem told us at point B, the kinetic energy was 7.5. Those are joules. So change in, we usually take final minus initial, right? So 7.5 minus 1.2, we get a change in kinetic energy of 6.3 joules.